As part of Databricks Certified Associate Developer for Apache Spark 3.0 course, in the previous sectional module, we have gone through details about reading data from files into Spark data frames. Now we'll be going through the details about writing data from data frame into files. These are the topics which will be covered as part of the sectional module. First, we will validate datasets for writing into files. Then we will see overview of writing Spark data frames into files. We'll also understand steps to follow to write Spark data frames into files. Then we'll actually start working on writing Spark data frames into CSV files. Then how to specify header while writing Spark data frame into CSV files. How to use compression, specifying delimiter. Also, we'll understand how to use options while writing Spark data frames into CSV files. You should be able to leverage this knowledge even with other file formats. Then we'll actually see writing Spark data frames into JSON files. We'll also go to the details about compression while writing Spark data frames into JSON files. Then we'll actually see writing Spark data frames into Parquet files. We'll also go to the details about compressing while writing Spark data frames into Parquet files. Also, we'll go to the details about different modes that are available to write Spark data frames into files. At the end, we'll also go to the details about Coalesce and repartitioning of Spark data frames while writing into the files. Ability to write the data from data frames into files is very important from both certification perspective as well as projects perspective, and hence make sure you go through all these details and be comfortable with those. As part of this section, we are going through the details related to writing data from Spark data frames into files using Spark APIs. Let's go ahead and quickly validate datasets which will be used to create data frames before writing those data frames into files. You can actually run all the cells in one shot. We have explored almost all these code snippets in the past. We are just validating whether the folders contain the files or not. As long as the cells doesn't throw any errors, we should be able to move forward to the subsequent lectures in this section. If there are any errors, you need to make sure that the errors are troubleshooted. You need to make sure you have all the required datasets, then you should be able to move forward. Now let's click on this. It will take care of running all the cells in this notebook. We will wait until all the cells are run. If there are any errors, we will actually troubleshoot and we'll actually fix those errors. Most likely there shouldn't be any errors. You can see that there are no errors at all. All the cells have executed successfully, which means we have all the required datasets to explore the details about writing data from data frames into files using Spark APIs. As part of this validation, we have validated the CSV files under public retail DB. You can see the location here. This contains CSV files. We have also validated the files under a public retail DB JSON, which contain JSON files. You can actually see here. Also, we have validated the Parquet files which are available under /user /login username /retaildb Parquet. Let me scroll down. You can see here. This is related to validating Parquet files. Also, we have validated the files which are pipe delimited. Let me scroll down and let me review the details here, which means we have successfully validated all the 4 types of files which are there as part of this environment. We'll be using these as and when it is required. As part of this lecture, let's get an overview of writing Spark data frames into files. When it comes to writing data which is in Spark data frames into files, you need to use certain APIs that are available on top of dataframe.write. Dataframe.write is of type dataframe writer. Dataframe writer exposes several APIs such as CSV, JSON, ORC, Parquet, etc. These are all direct APIs based upon the file format. Also, we have format and save. As part of format, we should be able to pass valid file format, and as part of save, we should be able to pass the location. Data will be returned to the target location. All these are exposed on dataframe writer. When we actually create the dataframe, it exposes an attribute called as write. Write is of type dataframe writer. Once you have the dataframe writer object from dataframe, then we should be able to use either of the approaches to write the data to the target location. Also, we should be able to specify options as arguments as well as using functions such as option and options. It is similar to what we have seen with respect to read. However, when it comes to read, it is available on top of Spark session object, whereas write is available on top of dataframe. When it comes to read, it is of type dataframe reader. When it comes to write, it is of type dataframe writer. The supported file formats out of the box are nothing but CSV, text, JSON, Parquet, etc. We have direct APIs for each of these supported file formats. Also, we should be able to easily plug in the external file formats such as XML and Avro. These are industry standard file formats. Even Spark supports that, but we have to install some external libraries to take care of it. On top of these things, if you are using a specific file format provided by a specific vendor, they might provide you the plugin. Using that plugin, you should be able to use even the other types of file formats. Keep in mind that for all supported file formats, we have direct APIs on top of dataframe writer object. You can see that df.write, where df is dataframe, is nothing but dataframe writer object. We'll be demonstrating very soon. On top of dataframe writer objects, we have these APIs directly. For all other file formats, you have to use the combination of format and save after you load the required libraries into the session in which we are trying to process that specific file format data. That being said, from the certification perspective, the important file formats are nothing but CSV, JSON, Parquet. Other file formats are not that important, but if you have good handle on these three file formats, even with respect to other file formats, you should be able to explore and should be able to answer the questions without any issues. Also, it is very important for you to understand details related to writing data in compressed format. We will be going through all these details as part of subsequent lectures in this sectional module. For now, let's get an overview of typical process using which we typically write the data into the target location. In this case, we will be writing data from the data frame into the target location. Now, I'm actually creating a data frame by name courses_df. This piece of code will actually take care of creating a data frame for us. Once the data frame is created by name courses_df, we should be able to pick that data frame. Then we should be able to paste here. Then we can actually say dot and hit a tab. You can see that there are a bunch of attributes and functions. All those which doesn't have circular brackets at the end are nothing but attributes, or all those which you have I at beginning or instance here, they are nothing but attributes. All those which have circle brackets or F here, they are nothing but functions. You can actually see the details here. You can see that there is an attribute by name write. Now let's check the type of the write. It is very important for you to understand these internals. You can see that write is of type dataframe writer. Now let's pick this attribute which is of type dataframe writer, then say dot and then hit a tab. We should be able to review all the functions as well as instances that are available on top of it. There are no instances as part of write. You can actually scroll down. It has only functions. So you have direct functions such as CSV, JSON, ORC, Parquet, text. These are the ones which are supported out of the box using Spark APIs. However, if you want to save it in Avro or XML format, you have to load some third-party libraries, and then using format, you should be able to specify the type based upon the documentation of that specific file format. And then you should be able to use save. As part of the save, you should be able to specify the path. Data will be written into that location using the format that is specified using format function. Also keep in mind that when it comes to format, we should be able to pass supported file formats also. So in case if you want to use format and save combination to write data in data frame in CSV file format, as part of format, you should be able to say CSV, and then as part of save, you should be able to specify the path. In the specified path, the data in the data frame will be written in the form of CSV. We'll be seeing quite a few examples as part of subsequent lectures in this sectional module. You will understand what I'm talking about at that time. That being said, to actually give a demo of how we can actually write the data to target location, let me use JSON. When it comes to JSON, we should be able to either use direct function like this, or we should be able to use format also. First, let me actually demonstrate using JSON. In this case, I just have to say JSON, then I have to specify the path. To specify the path, let me actually import something called as getPath. So let me say getPath. Let me also define a variable by name username. Let me say getPath.getUser. It will actually take care of assigning the login user to variable by name username. So username will contain login user. For my environment, it is nothing but root. Now I would like to use the path derived by this. So in this case, I can say F. Then I should be able to say /user /username in curly braces. Then courses. I have already used this location in the past. I would like to overwrite if the location already exists. For that, I should be able to say mode equal to overwrite. Let me clean this up. Now let me say overwrite for mode. Now let me run this. You can see that data is being written into the files. In this case, data from dataframe courses_df is being written into the file. We should be able to pick this. Then we should be able to use the code snippet which says dbutils.fs.ls. Then we should be able to specify the path. Now if I run it, I should be able to see the JSON files in this. You can see there are multiple JSON files. This is how you should be able to use direct APIs to write the data to the target location. Also, we should be able to use the combination of format and save. If I have to take care of this using format and save, it will look like this. In this case, I have to say dataframe.write, then format, As part of the format, I have to pass JSON because I want to write the data in JSON format. Then I have to use save. Now we should be able to run it. Take care of writing the data to the target location in JSON file format. So this is the alternative approach when it comes to writing data in Spark data frame into files. This is just a beginning. You just make sure you understand different ways using which we can write the data from data frame into the files. We'll be performing quite a few tasks so that you are really comfortable about writing data from data frames into files using different types of file formats, and also we'll actually go to the details about mode when it comes to text files, especially CSV file format. What are the important options we need to keep in mind? Also, we'll actually go to the details related to compressing the files. Let's go through all the lectures, then everything should be clear for you. As part of the previous lecture, we have gone through the details related to overview of writing data from Spark data frames into files. In this lecture, let's go through the steps we need to follow to write Spark data frames into files. Then we'll actually perform tasks to understand how to write data from data frame into files using different file formats. First, we need to ensure we understand the schema of the data frame. Sometimes there might be some incompatibility issues between data frame column types versus the data types which are supported by underlying file formats which are being used while writing the data into the files. You need to make sure you understand those nuances. In those scenarios, you might have to typecast the data in the data frame into compatible types based upon the file formats you are going to use to write the data to the target location. Also, you need to ensure you have write permissions on the target location. Obviously, if you do not have write permissions on the target location, you will not be able to write the data into the target location. In this case, when I say you, it is not about you, it is about the application user that is being used to run your application. That user should have write permissions on the target location. Also, you need to understand whether data should be overwritten or appended or ignored, or it should throw exception in case target folder already exists. Depending upon the requirements, you have to choose appropriate option, and then you have to come up with the logic. Sometimes you might want to overwrite the data, sometimes you might want to append the data in the target location. We will be seeing a few examples so that you understand what I'm talking about. Also, before writing data from Spark data frame into files, you need to decide whether you would like to compress the data or not. Also, you need to make sure you understand whether the files will be compressed or not by default. Based upon these two, you need to make certain decisions, and then you have to write the data into the target location. By default, some of the file formats are not compressed. However, the requirements might say compress the data while writing into the target location. You need to understand how to specify specific compression algorithm while writing the data into the target location. Example is CSV and JSON. When it comes to CSV and JSON, by default, compression is not enabled. You can compress using compression algorithms such as gzip, snappy, etc. Also, when it comes to file formats such as Parquet, by default, the files are compressed using Snappy. Sometimes the requirements might say save the files in the form of Parquet, but don't compress. In that scenario, you might have to change the default behavior and make sure that the files are not compressed. So you need to make sure you do enough research with respect to whether we want to compress the data or not. If at all we want to compress the data or not, we also need to understand the default behavior. If we have to change the default behavior, we should know how to change the default behavior. So based upon the analysis, we need to use appropriate APIs along with right arguments based upon requirements. Then only it will actually work as per the expectations. Otherwise, you will be running into quite a few issues which will be very tough to support. Keep in mind that when you actually start working on projects, when you have to write data from data frames into the files, don't just blindly use whatever API that is comfortable for you. You have to make sure you understand the requirements and design. Based upon the requirements and design, you have to come up with the appropriate file format, and then you have to use the appropriate API based upon the file format you want to use while writing the data from Spark data frame into the files. From the certification examination perspective, you need to make sure you are familiar with all these terms. If you are not familiar about all these terms, you will not be able to understand which function will work as per the question they have asked as part of the certification exam, and hence make sure you are familiar with all these terms, especially compression, overwrite, append, ignore, or throw exception in case target folder exists, analyzing the schema, how to specify the compression algorithm. All these things you should be familiar with. We will be going through all those as part of the subsequent lectures in this section. By the end of this section, you should be well equipped about writing data from Spark data frames into files. As part of this lecture, let us understand how to write Spark data frames into CSV files. When it comes to writing data from Spark data frames into CSV files, we have multiple approaches. The first one is using direct API like this. It is available on top of data frame writer attribute that is part of data frame. In this case, df is nothing but data frame. That being said, if you are using direct API like this, you should be able to specify the path to which you want to write the data from data frame in the form of CSV files in a single quotes like this. The second approach is using data frame writer. You should be able to invoke something called as format. As part of the format, you should be able to pass CSV like this. Then you should be able to specify the path to which you want to write the data in the form of CSV using save like this. The column names from the schema can be added as header to each of the files by saying header equal to true. However, when it comes to default, header equal to none, which means the column names from the data frame will not be added as header to each of the files. We can also write the data into files using characters other than comma as delimiters or separators. We have to use a keyword argument called as sep for that. When it comes to writing data from data frame into the files in the form of CSV, we should be able to compress the data. We will go to those details as part of the subsequent lectures. For now, let's understand how to write data from a data frame into CSV files using either of the approaches. First, I am creating a data frame by name courses_df. For that, I am actually using this list of dicts. First, let me create this list. Using that list, let me first create data frame by name courses_df. Now courses_df is nothing but data frame. You should be able to preview the data by running this. You can see the data in courses_df. Also, you should be able to preview the schema by saying courses_df.dtypes. Dtypes will give us both column names as well as the data types in the form of a list. Let me copy this. Now let me add a cell here. Now let me say dtypes. You can see the column names as well as the corresponding data types in this data frame. Now we should be able to create a variable by name username. I'm actually creating a variable by name username so that I can actually specify the dynamic path. First, let's validate whether this location contains the files or not. You can see that the location contains the files. We should be able to clean up by using appropriate command. Now let me actually say rm in place of ls. As this is folder, we should be able to use recurse. We should be able to set it to true. Now we should be able to run this. You can see that the folder is deleted. Now if you run this, it will not return anything because the folder is deleted. It is actually throwing error. Now we should be able to run this. It will take care of copying the data from the data frame called as courses_df into this location in the form of CSV. You can actually validate by running this. You can see that there are multiple files in this location. You can see the extension of these files. There are 4 of those files. When it comes to the number of files, they will be determined implicitly based on several factors. We might not have direct control, but we can control the number of files that can be used using a special function called as Coalesce. We'll be talking about at a later point in time. For now, just remember that the default number of files will be determined implicitly based on several factors. Also, when we use write.csv on top of data frame and pass the path without any additional options, it will use default separator or delimiter. The default delimiter or separator while writing data from data frame into CSV files is nothing but comma. You can see the details here. Now we should be able to use format also. Let me copy this. Let me add a new cell here. Let me paste. Now let me say format. As part of the format, we should be able to pass CSV in this manner. When we use format, we have to use save to pass the path. Now you can try running it, however it will fail. You can see here the reason why it is failing is because when we run this, it have created this folder. As the folder already exists, it is failing. So when you use write APIs to write the data from the data frame to the target location, if the target location already exists, it will throw error like this. It is the default behavior with respect to locations into which we are trying to write the data using write APIs. In this case, either we have to delete this folder or we have to use mode equal to overwrite so that the folder is overwritten. For now, let me actually take this. This will take care of deleting the folder. Once the folder is deleted, we should be able to run this to actually get the data from data frame courses_df into this folder in the form of CSV. You can see that it have ran successfully. You can actually run ls once again. So let me actually copy this, paste here. You can see that the files exist in this location. There are 4 CSV files. Now let's preview the data using spark.read.text. As these are text files with CSV format, I would like to review the delimiter. One of the ways to review the delimiter in text files is by using this approach. This will actually create a data frame using one column. Each and every value in that column will be complete line in the file. You should be able to review the delimiter. On top of this data frame with one column, I am actually using show function with truncate equal to false so that we can preview the data of each and every record completely. Now let me run this. You can see the data. If you review the records, you can see there is comma as delimiter in each and every record. This is how you should be able to write data from Spark data frames into CSV files and also validate. Keep in mind that the default behavior is to use comma as delimiter while data is being written into CSV files, and also keep in mind that if target folder already exists, it will just fail saying that folder already exists. Now let's go to the details about exploring different options to customize the behavior while writing data from data frames into CSV files. As part of this lecture, let's go to the details related to specifying header while writing data from Spark data frame into CSV files. First, let me create data frame. In this case, a data frame by name courses_df is created. Now let me run this to create a variable by name username. Let's validate the location here. You can see that it has several files. Ignore these files. These are related to overhead associated with the write operation. The actual files are nothing but these ones. The files with the CSV extension are the actual ones. At this time, we have 4 CSV files in this location. Now, first, let's run this and see what happens. So in this case, if you keenly observe, I'm using Coalesce of 1, and also I'm saying mode equal to overwrite. Also, I'm specifying header equal to true. When I use Coalesce of 1 like this, instead of creating 4 CSV files for our small dataset, it will only create 1 file. That is the purpose of Coalesce 1. As the target folder already exists, by default, if you don't specify mode equal to overwrite like this, it will fail saying that target folder exists. To overcome that, I'm actually using mode equal to overwrite so that I don't have to delete the folder and then run this piece of code. It will take care of overwriting the existing data with the data in the data frame courses_df. Also, as part of this lecture, I would like to emphasize on specifying header, and hence I'm actually having header equal to true. This is how you should be able to specify header while writing data from data frame into the files. Now let's run this. You can see that the data is being written into this location. You can actually validate. As we have Coalesce of 1, we should be seeing only one CSV file. You can see only one CSV file here. Now you should be able to preview the data by saying spark.read.text. Then let's use this path. It will take care of creating a data frame with a single column. This will facilitate us to review the data. Now let me say show. Let's run this. Let me actually say truncate equal to false so that we can actually get complete data. Now if you review the output, instead of just having the data which starts from second record, it also have column names. This is nothing but header. You can also validate by using spark.read.csv with header equal to true. Then you should be able to get column names using the header that is part of this CSV file. Let me add a cell here. Now let me say spark.read.csv. Let me specify the path. Let me say header equal to true. Now let me say show. Let me run this. You can see the output. The column names are from the header. This is how you should be able to use header equal to true to actually specify the header while writing Spark data frame into CSV files. The header will contain the column names from the original data frame. In this case, the original data frame is nothing but courses_df. If you review the column names of courses_df, it is same as what we are seeing as part of this output. Whatever columns you are seeing here, the same columns are written course ID, course name suitable for enrollment, stars, number of ratings. So when we say header equal to true, the columns of the data frame will be placed as first row in the CSV file. When we actually use spark.read.csv with header equal to true, that first row will be considered for determining the column names while creating the data frame again. That being said, we should be able to use even this approach to actually write the data frame courses_df into CSV with header. In this case, we are using format and save combination. As part of format, we have specified CSV. As part of save, we have specified the path. We can also specify options such as mode equal to overwrite and header equal to true. Even as part of save, you can actually run it. This will also take care of writing the data which is there as part of courses_df data frame into this location. You should be able to validate this piece of code. You can actually review the CSV file. You can review the name of the file. It will be different from the previous one. Let's scroll up and let's review the file name here. If you look at this, it says 982 blah 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 381. Let me actually check it here. It is something else 431c000.csv, which means the name of the file is different, which means it is a different file than what we have seen earlier. This is being created because of the overwrite. Once again, you should be able to use this piece of code to validate whether header is actually there as part of the CSV files that are created under /user/username courses. You can actually see the output. You can see the call names. This is how we should be able to specify header while writing data from Spark data frame into CSV files. Make sure you are really comfortable with this. As part of this lecture, let's understand how to use compression while writing data from Spark data frame into CSV files. First, let's create data frame by name courses_df. You can see that courses_df is created. Now let's run this piece of code so that a variable by name username is created. First, let's delete the folder which we have used earlier to write the data into the data frame. Now user root courses will be deleted when we run this piece of code in my environment. In your environment, based upon the user you have used to login, that specific folder will be created. Let's run this piece of code. In this case, I am not using any compression. We will see the default compression behavior and we'll take it further. Now, if you run this command, you can see files with the CSV extension. This is the CSV file which is created. There is no gz or zip or anything else, which means it is plain CSV file. It is not compressed by default. You can also get the help on write.csv on top of data frame. When it comes to dataframe.write.csv, the first argument is nothing but path to which we want to write the data from data frame into. Then we have additional options such as mode, compression, header, so on and so forth. We have already used header to actually get the call names of the data frame as first row in the CSV files. Also, we have used mode to actually overwrite the files in the target location so that we can actually write the data from data frame into the files without deleting the folder. On top of this, now we are actually talking about compression. There is a keyword argument related to compression. By default, it is none, which means when it comes to writing data in the form of CSV, the files will not be compressed by default. Now let's go to the details related to compression as part of this documentation. Let me scroll down here. You can see that as part of the compression, you should be able to specify these as values. The values can be either none, which is default, or bzip2, or gzip, or lz4, or snappy, or deflate. So these are the compression algorithms which we can leverage to actually compress the files which are being generated because of write.csv. The way you can actually compress is like this. In this case, I'm trying to compress the CSV files in gzip format. Now let's run this. We have used compression keyword argument, and as part of compression keyword argument, we have passed gzip as value. Now we should be able to run it to check the files. You can see the extension of this file. It have gz in it, which means the file is compressed using gzip algorithm. When it comes to reading the data from compressed files, you don't need to worry too much about uncompressing the files. The implicit behavior of read APIs will actually take care of uncompressing and getting the data as long as we use appropriate API based upon the file format that is there as part of those compressed files. In this case, the compressed file, which is nothing but this one, have CSV file, and hence we should be able to use spark.read.csv. We don't need to do anything extra with respect to reading compressed files into data frame. While writing the data frame into CSV files, we have specified header equal to true, which means the first row in the file will be nothing but column names separated by the delimiter. In this case, you should be able to say header equal to true while reading the files from this location so that the first row can be used to determine the column names. Let's run this. Let's review the output here. You can see the output as per the expectations. We can also use the approach of format and save to compress the data. In this case, I'm using a different compression algorithm. It is nothing but snappy. You should be able to use even this approach to compress the data. Let's run this. Now the data in the data frame is being written into the CSV files using snappy compression. Once it is done, we should be able to run this to review the file names so that we understand whether the files are actually compressed or not. Now it have ran successfully. Let's run this. You can see the output here. There is one file with a snappy extension, which means this file is compressed using snappy algorithm. Even when it comes to files with a snappy algorithm, we don't need to worry too much about uncompressing to actually read the data from this file into the data frame. We can use the same code which we have used earlier to read the data even when files are compressed using snappy. Earlier we have used the same code when files are compressed using gzip as well as when the files are uncompressed. It will work in exact same manner. You can see the output here. There are no issues with respect to the output, which means we don't need to worry too much about uncompressing the files when the files are compressed using supported compression algorithms. This is how you should be able to use compression while writing data from Spark data frame into CSV files. When it comes to reading the files which are in compressed format, we don't need to worry too much as long as the files are compressed using supported compression algorithms. As long as you understand the file format of underlying files in compressed files, you should be able to use the appropriate APIs to read the data from those files into the data frame. As part of this lecture, let's go through the details related to specifying delimiter while writing data from Spark data frame into CSV files. The default delimiter is comma. Many times we might have to change the default delimiter to something else. Let's go through the details about how to change the default delimiter to pipe in this case. First, let's run this. As part of public retail underscore DB, we have CSV files already. You can actually run this to read the orders dataset. You can see that data frame is created. You should be able to preview the data as well. You can see the output here. Because we haven't specified the schema, the column names are system generated. You can see the data for these 4 columns. Now let's try to write this data frame into CSV using pipe as delimiter. Once we understand how to write orders dataset which is in data frame into CSV using pipe as delimiter, we'll also go to the details about reading files related to all the other folders such as categories, customers, departments, order items, as well as products into data frame, and then using those data frames about how to write into CSV files using pipe delimiter. We'll actually go to the automation process using simple Python code. That being said, first let's run this. It will take care of creating 3 objects. One is username, second one is input directory, third one is output directory. As per my environment, this output directory will be /user/root/retail_db_pipe because username will be root in my case. Now let me actually run this piece of code. It will actually take care of writing the data frame, which is nothing but this one. You can see here df is nothing but data frame for orders dataset. Now this piece of code will take care of writing that data frame into CSV using pipe as delimiter. This is how you should be able to specify the delimiter using sep as keyword argument. Also, we are using Coalesce of 1, which means it will only use one file. If the target location exists, it will be overwritten because we are using mode of overwrite. You should be able to specify overwrite even in this manner. You can also use keyword argument if you are interested. That being said, before running this, let's go to the help related to df.write.csv. For that, I can say help, then df.write.csv. You can go to the details here. You see there is a keyword argument called as sep. By default, it is none, which means it will use comma as the delimiter. If you wanted to change the delimiter, then you have to specify the delimiter using sep keyword argument. That is what we are doing here. Now, this will take care of creating the CSV files under this location using pipe as delimiter. Now, let's run this. You can see the file here. You can also validate the data by saying spark.read.csv. The location is nothing but this one. If I do not specify the separator, if I say show like this, then you can see the output here. It is considered as a 1 column data frame. It did not consider as a multi-column data frame. Now I should be able to say sep equal to pipe is the delimiter which we have used while writing, and hence let me say pipe. Now I should be able to run it. You can see the output here. As there is no header, the column names are system generated. Now let's go to the automation process. This piece of code is not required because we do not have any additional folders than the 6 folders which we are interested in, and hence I have removed the if condition. When it comes to dbutils.fs.ls, it will actually return list of file info objects. Each object will be of type file info. It has several attributes. One of them is nothing but path. We are interested in path so that we can actually read the data. Let's go through one step at a time so that you understand what is going on here. Now first let's run this piece of code. I can actually use input dir. So let me use input dir itself. You can see that it have returned list of file info objects. These are all nothing but file info objects. As part of file info objects, we have attributes such as path, name, etc. So in this case, we are interested in path. It will actually give us this complete path. So we are actually saying converting data in a specific path for each file detail. As there are 6 of them, this for loop will iterate 6 times. each time file details will contain details related to one file info object. So it will actually print saying converting data in this path folder from comma separated to pipe separated. As the original data is comma separated, we are actually saying spark.read.csv file details.path. This is a valid path using which we should be able to convert the files in this location into the data frame. Then we are actually extracting the folder name. So this is nothing but the folder name. We are saying file details.path, which is nothing but this one. Once you use split on top of it, / as delimiter, as part of first element in the list that is written by split, it will contain this value. The second element will contain this value. The third element will contain this value. The fourth element will contain this value. There will be a fifth element which will be empty. From the end, you can access the last element using -1. The second element can be accessed using -2. If you say -1, it will actually return empty string. In this case, you have to say -2 to actually extract the folder name. So that is what is happening here. When I say file_details.path.split of / of -2, it will actually give us this folder name. And the folder name is actually made part of the target location while using write.csv. If you review the code related to write.csv, we are saying coalesce of 1 on top of data frame, which means the data in the data frame will be written to one file. We are also using mode of overwrite. It actually takes care of overwriting the existing files if the target location already exists. When it comes to output directory, you can see the definition of output directory by scrolling up here. It is nothing but /user/username /retail_db_pipe. Username is derived from this piece of code. In my case, it is root. It will be different based upon the environment where you are running this notebook. That being said, now the path will be determined based upon the output directory and folder name. All the files which are there in these locations will be read into the data frames. Then the data frames will be written into the target locations based on the folder names. All the files will be created using pipe as delimiter because we are using CSV with sep equal to pipe. Now let's run this. It will take a moment. You should be able to see details with respect to the progress. You can see that so far categories, customers, departments and order items are converted from CSV to pipe. Now even the other two are converted. As the CSV files with comma as delimiter are actually converted to pipe delimited files, let's make sure we validate one of the folders in the target location. I'll be using orders from this location. First, let's create schema. This will take care of creating schema for our orders dataset. Now we should be able to say spark.read.schema. Then we should be able to pass the schema. Then as part of CSV, we should be able to specify the path like this. Now let's run this and see what happens. You can see that the data frame is created. It contains all the 4 fields. However, when I run this, you can see that it is displaying null values because we haven't specified the delimiter. It means the files in this location are not comma separated files. Now let's specify sep equal to pipe like this. Then let's run this. Now if we say orders.show, you can see the data as expected, which means the location which is specified here contains CSV files with pipe as delimiter. This is how you should be able to specify delimiter while writing Spark data frames into CSV files. You should also be familiar about validation process. It is very, very important from the perspective of projects. From the certification perspective, you just need to make sure you have better handle around the APIs. As part of this lecture, let's go to the details about using options while writing data from Spark data frame into CSV files. Even though I'm demonstrating using CSV, the same concepts apply even with other file formats. However, keep in mind that the options might vary depending upon the file format you are using. That being said, first let me run this. This folder contains several subfolders. You can see the subfolders here. They are nothing but categories, customers, departments, order items, orders, products, etc. For this demo purpose, I'll be using orders dataset. First, let me define the schema. Now let me create data frame by name orders. Now the data frame is created. You can also preview the data. You can see the output here. Now let's look at the help on orders.write.csv. If you go to the help related to orders.write.csv, there are quite a few keyword arguments. Most of these keyword arguments can be considered as options as well. When it comes to those keyword arguments which are considered as options, either you can pass those as keyword arguments as part of CSV, or you should be able to use option or options. When it comes to option, you can pass only one option at a time. First, let me run this. Now we should be able to review the syntax of option. When it comes to option, it takes 2 arguments. They are nothing but key and value. Key is always of type string. Value can be of different types. When it comes to key such as sep, value can be of type string. When it comes to keys such as header, value can be either of type string or boolean. So the type of value will differ based upon the key which we are trying to set. That being said, option always returns data frame writer. As it returns data frame writer, you should be able to invoke option multiple times to actually set all the keys with the corresponding values. You can also use options in place of option. When it comes to option, you have to trigger multiple times. When it comes to options, you can only trigger once and you should be able to set all the options in one shot. Let's review the details so that you understand what I'm talking about here. First, let's make sure that this cell is run. It will take care of creating two variables, input directory and output directory. Now you can see the usage of option here. Even before this, let's understand how to use keyword arguments rather than using options. When it comes to using keyword arguments, it will be like this. Let me actually use this piece of code. Let me paste here. Now, as part of CSV, I should be able to pass all keyword arguments like this. Now I should be able to delete it. Now let me run this. It will take care of copying the data from the data frame into CSV using pipe as delimiter with header, and also the file should be compressed using gzip. Now we should be able to validate by saying dbutils.fs.ls. Then the output path which is used here can be used as input path here. Now we should be able to review this. You can see there is one file with csv.gz, which means the file is of type CSV and it is also compressed using gzip algorithm. You can also use spark.read.csv to read the data from this location. Let's give it a try. In this case, I am saying spark.read.csv, then specify the path, then sep equal to pipe, header equal to true, then infer schema equal to true. It will take care of typecasting the types of each and every column into appropriate ones. We should be able to say show to actually preview the data. So let me say show and let's preview the data here. You can see the data as per the expectations. Now in place of keyword arguments to CSV, the way it is done here, if you would like to use option, this is how it will look like. In this case, as part of option, we are actually passing compression as key and gzip as value. When it comes to header, we are actually passing true as value. When it comes to sep, we are passing pipe as value. There is no option for mode, and hence we have to specify mode of override like this only. When it comes to using keyword arguments as part of CSV, you can also say mode equal to override, but you will not be able to use option for mode. Either you have to use mode of override like this, or you have to say mode equal to override as part of CSV. Now, using options, let's run this. In this case, I am using option thrice. That's why I'm saying options. Now it have ran successfully. We should be able to review the location to see if the files are using appropriate extension or not. You can see one file here. The extension is nothing but CSV and gz, which means the file is compressed CSV file. You can also validate by running this piece of code. You can see that data frame is created successfully. You can run this to preview the data. You can see the data as per the expectations. Now, instead of using option thrice like this, we can also use options, and we should be able to pass all the options as keyword arguments. You can see the usage of options here. As part of options, we have keyword arguments. Once again, I'm reiterating, you will not be able to specify mode as part of option or options. It can be specified like this, or you can also specify mode as keyword argument as part of the CSV. Even this one will work in the exact same manner. You can see that data from data frame orders is being written into pipe delimited files in this location. You should be able to validate by running this. It will take care of creating the data frame. Now this will take care of previewing the data. So let's preview the data as well. You can see the output as per the expectations. As demonstrated at the beginning, you can also use keyword arguments in this manner. I have already demonstrated this, and hence I am not actually running this once again. I'll be deleting it. One of the common usage with respect to options is there might be a scenario where you might get the options in the form of dictionary. Once you get options in the form of dictionary, you should understand how to pass it to the options in the form of keyword arguments. So for example, in this case, there might be a dict like this. The name of the dict can be options. It might contain 3 elements. The key for the first element is nothing but sep. The value is nothing but pipe. Then the key for the second element is nothing but header. The value can be true like this. Then The key for third element is nothing but compression. The value can be snappy or whatever compression algorithm that is supported. You have options like this, which is of type dict. You should be familiar about how to convert this to varying keyword arguments and use options. This is one of the common uses with respect to options. So in this case, what I need to do is I just have to copy this, paste here. As part of options, I just have to say star options. In this case, this options is of type dict. A dict can be converted to varying keyword arguments using star options like this. Now let's run this. You can see that it is running. We need to validate whether it is working as per expectations or not. For that, we should be able to use the ls function on dbutils. So let me copy this. Let me paste here. Now let's review the extension for the file. The extension for the file is nothing but csv.snappy, which means the files are written as per our expectations. If you look at the dict here, we have said snappy as compression algorithm, and it have created the files using snappy compression algorithm. We can also use this piece of code to validate whether data can be read without any issues. Let me paste here. Let me run this. We don't need to worry too much about passing compression details while reading the data using read APIs. As long as we use the appropriate API based on the file format that is there as part of the compressed file, we are good to go. In our case, as part of this file, which is using Snappy as compression algorithm, the format of the file is nothing but CSV. As this is CSV file, we are able to read the data from the file using spark.read.csv. It will take care of uncompressing the data, and then it will actually create the data frame using the data in the file. As we are using show here, we are able to preview the data as well. This is how you should be able to use options while writing data from Spark data frame into CSV files. There are three different approaches. The first approach is using keyword arguments with APIs such as CSV. The second approach is using multiple option functions. The third approach is using options. When it comes to options, you should also be familiar about how to convert a dict to varying keyword arguments so that we can pass all the options in one shot. Make sure you are comfortable with all the three approaches, and also make sure you have good idea about the APIs. When it comes to certification exam, there might be some emphasis on the options in the form of APIs. As part of this sectional module, we are going to the details related to writing data from Spark data frames into files. Already we have gone to the details related to CSV files. Now let's go to the details related to JSON files. First, let's create data frame by name courses_df. You can see here courses_df data frame is created. Now let me create an object by name username. It contains the logged in user. Let's make sure the folder /user/logged-in-user/courses is deleted if it exists. For that, we should be able to use this piece of code if we are using Databricks environment. You can run it. You can see that it have returned true. As the folder exists, it is deleted, and you are seeing true here. Now we should be able to review the help with respect to dataframe.write.json. Let's say help here, then add courses_df.write.json to it. If you would like to review the help related to this function, you can actually go to the details here. You can see that JSON takes several keyword arguments. Based upon your requirements, you should be able to specify the keyword arguments, and you should be able to achieve the desired results. That being said, now let me scroll down. You can actually review the output here. It says data frame, then .coalesce of 1. It will take care of writing the small dataset into one file. Then we are using write. Then we are actually specifying JSON. JSON is a direct API to actually write the data frame into JSON files. As part of JSON, I'm actually saying path here, then mode equal to overwrite. In case if the target folder already exists, it will actually delete the JSON files in it, and it will actually place the new JSON files based on the data that is there as part of this data frame. If the target folder doesn't exist, it will just create the folder and write the data into that folder in the form of JSON. When the target folder doesn't exist, whether you have mode or not, it doesn't matter. It will work in exact same manner. For now, let's run this. It will take care of writing the data from this data frame into JSON files in this location. Now let's run this to review the location. You can see that there is one JSON file. It is nothing but this one. This is the fully qualified path of the JSON file in this location. That being said, we can also use format along with save in this manner. As part of format, we should be able to specify JSON to actually write the data in this data frame in the form of JSON. When you use format, we have to use save. As part of the save, we should be able to specify the path to which we want to write the data frame to. Even this piece of code will actually write the data from Coalesce_df data frame into JSON files in this location. As mode equal to overwrite, whatever file we have here, this is the file. This file will be overwritten and a new file will be created with the same dataset we have as part of data frame Coalesce_df. Now let's run this. You can see the name here. It says 4-1-c 30s.json. Here it is saying 3-1-c 30s.json, which means the existing file is overwritten with the same dataset that is part of Coalesce_df data frame. Now we should be able to validate whether the files are in JSON format or not, and also we should be able to validate whether the dataset have required columns or not by using spark.read.json here. The reason why we are using JSON here is because the location which is specified here contain the JSON files. Now we should be able to run it. We can actually see the output as expected. We should see data related to all the fields in courses. Courses contain data related to all these fields. They are nothing but course ID, course name, enrollment, number of ratings, stars suitable for, etc. Also, if you actually look at the output of D types, you will be able to get call names along with the corresponding data types. You can see that course ID, enrollment, number of ratings are of type BigInt. When it comes to course name and suitable for, they are of type string. Stars is of type double. This is how you should be able to write data from Spark data frames into JSON files. As part of this lecture, let's go to the details related to compression while writing Spark data frames into JSON files. First, let's create the data frame by name Coalesce_df. Now the data frame is created. Let's run this to define a variable by name username. Now we should be able to use compression like this. Before running this, let's review the existing files. Already we have files in this location. As part of the previous lecture, we have used the same location and we have written the data from the data frame into the files in this location using JSON format, and hence we should be able to use this piece of code to actually review the location. When it comes to default behavior with respect to compression, JSON files will not be compressed. You can see the name here. There is no extension related to compression algorithm, which means the files are not compressed. Now let's run this with compression equal to gzip and see what happens. Now the data frame is written into the JSON files in this location. Now let's run this. You can see the existing file being overwritten here. If you look at the extension of the file, it says json.gz, which means the files are compressed using gzip algorithm. When it comes to reading data, when data is compressed, we don't need to worry too much about specifying any algorithm. You just have to specify the path with the appropriate API. This API should be based on the file format that is being used as part of the compressed files. As long as we are using correct API, it should work without any issues. Now let's run this. You can see that output is as per the expectations, which means using this approach, we are able to compress the data without any issues. Also, while using compression like this to compress the data, you should be familiar about the supported compression algorithms based upon the file format. For that, you should be able to review the help and then you should be able to take it further. In this case, I can actually say help, then courses_df, then write.json. You can see compression is the keyword argument. By default, it is none for JSON. You can scroll down. As part of compression, you can either pass none, which is default, or bzip2, or gzip, or lz4, or snappy, or deflate. These are the codecs or algorithms which can be leveraged while compressing the data in JSON files. By using a compression equal to one of these strings, we should be able to write the data in data frame into JSON files by taking care of compression using a specific algorithm. Now we should be able to even use format and save in place of JSON. Let's understand how to use format and save and write the data from data frame into JSON files while using compression. Let me make sure it is copied. Now let me paste here. We should be able to use format here. Let me say format. As part of the format, let me pass JSON because we are trying to write the data in data frame into JSON files, and hence we have to say format of JSON like this. Now we should be able to say dot // then save. If you are using format, then you have to use save to specify the path and other options. Now we should be able to run this to actually take care of writing data from this data frame into JSON files while compressing using gzip algorithm. If you want to compress with a different algorithm like snappy, you should be able to say snappy like this. This will take care of writing data from data frame Coalesce_df in the form of JSON files in this location using snappy compression algorithm. Now let's validate whether the files are compressed using Snappy or not using this piece of code. I have copied it already. Let me paste. Let me run it. You can see the extension for the file. It is nothing but json.snappy. You should be able to review the size also. It might be big or it might be small. It all depends upon the data, but it will be different from either uncompressed or gzip compressed file. You can also validate whether we'll be able to read the data in this file or not by using this piece of code. I have already copied. Now let me scroll down. Let me paste here. Now let me run this. You can see the output as expected. This is how you should be able to compress while writing data from Spark data frames into JSON files. Make sure you are really comfortable with it. As part of this sectional module, we are going through the details related to writing data from Spark data frames into different file formats. So far, we have gone through the details related to writing data from Spark data frames into CSV as well as JSON. Now, let's go to the details related to writing into Parquet files. First, let's create data frame by name courses_df. Let's review the help by saying courses_df.write.parquet. As we have seen earlier, when it comes to data frame, it actually exposes attribute called as write. It is of type data frame writer. When it comes to data frame writer object, it actually exposes a function called as Parquet. We should be able to use it to write the data frame into Parquet file format. Let me run this. You can see the help on this. You can see that it takes path as well as keyword arguments such as mode, partition by, compression. We will go through some of these keyword arguments as we go along with this sectional module. If you wanted to explore any of the arguments, you should be able to go to the material here. It is almost same as what we have seen earlier. However, there might be different options depending upon the file format. Now let's run this to create an object by name username, which is of type string. It will contain the logged in username. Now, if you go through this piece of code, we are trying to write the data in a data frame called as courses_df into Parquet file format in this location, and hence we are using Parquet here. Also, if the folder exists, we would like to overwrite. That's why we are saying mode equal to overwrite. If it doesn't exist, it will just add the data by creating this folder. Then it will actually get the data in data frame into that folder in the form of Parquet files. Also, we are using Coalesce of 1 so that as we have very limited dataset, the data is not scattered into multiple files. Instead, the entire data is copied into single Parquet file. You should be able to run it. Let's wait until it is executed. Now it is executed. Now let's review by using this command. You can review the output here. There is only one file with Parquet extension. This is the only file which actually contains the data from the data frame. Also, if you look at the file name, it also has Snappy in it, which means these files are compressed using Snappy algorithm by default. Now let's review whether we will be able to read the data from this location or not using spark.read.parquet. Then we have to specify the location from here. Let me pick this location. I should be able to paste here. Now I should be able to say .show. We can review the output. The output should be as per the expectations if the files are written properly in that location. We have to wait until it is executed. You can see the output here. It is as per the expectations. Also, we should be able to use the D types to review the column names as well as the data types. Let me paste and let me replace show with D types. Now you can see the column names along with the corresponding data types. That being said, we can also use a combination of format and save like this. Even this piece of code will actually write the data from this data frame using Parquet file format in this location. As we want to write the data using Parquet file format, as part of format, we have to specify Parquet like this. As part of save, we have to specify the path to which we would like to write. We can actually specify the required options in this manner. In this case, we have said mode equal to overwrite, which means it will actually overwrite the existing file. Now we should be able to run this. When it comes to the previous run, the file name is nothing but 15-1-C30. Now, if we run this, the file name will be different. This time you can see 19 here. Earlier it was 15, now it is 19, which means the file name have changed. The file with 15 is already deleted because we are using mode equal to overwrite while using save along with format to write the data from data frame courses_df into Parquet files. Now we should be able to run this piece of code to confirm the data in this location is as per the expectations. You can review the output here. This is how you should be able to write data from Spark data frames into Parquet files. As part of this lecture, let's go to the details related to compression while writing Spark data frames into Parquet files. Already we have seen how to write data from data frames into Parquet files. Now we are talking about compression. First, let's create data frame by name courses_df. Now data frame is created. Let's create an object by name username. It is of type string and it will contain the logged in username in it. Now let's remove the /user/username/courses if it exists. As it is directory, we are actually specifying recurse equal to true like this. As part of Databricks environment, we should be able to use this to actually delete a folder. You can see the output here. It is saying true, which means the folder exists and it is deleted. Now, this is the piece of code which you have seen earlier to write the data from data frame courses_df in Parquet file format in this location. Let's run this. By default, Parquet files will be compressed using Snappy. You can actually review the file names by running this. You can see there is one file in this location. The extension of this file is nothing but Parquet. However, as part of the name of the file, we also have Snappy. It means the files are compressed using Snappy algorithm. Also keep an eye on size to see the difference with respect to size when we use either uncompressed format or other compression algorithm. Now, we should be able to validate whether we can read the data from that location or not by running this piece of code. You can see the output here. It is as per the expectations. However, if you would like to change the behavior of the compression, you should be able to see the help. But before looking at the help, let's make sure this folder is deleted. Now the folder is deleted. Now let me run this to get the help on dataframewriter.parquet. If you review the syntax of Parquet, it takes several arguments. The first one is nothing but path. Based on the path, the data from the data frame will be written into that location. Then we have 3 keyword arguments. They are nothing but mode, partition by, and compression. To customize the behavior of compression, we have to use this keyword argument. We should be able to scroll down here to get more details about compression. Let's go to the documentation here. It says compression codec to use when saving to file, which means whatever string that is passed as part of compression, it will try to use corresponding compression codec while saving file in the Parquet format. When it comes to values with respect to this keyword argument, they can be one of none, uncompressed, snappy, gzip, LZO, broadly, LZ4, ZSTD. These are supposed to be passed as strings. If you actually pass any of these strings, then the property spark.sql.parquet.compression.codec will be overridden. If you do not pass any value to compression, it means it will pick none. If it is none, it will actually pick the value from this property. Whatever is set as part of this property, that compression algorithm will be used. We should be able to review the value of this property by saying spark, then conf, then .get, then the property name. You can see the value of this property. It is nothing but snappy. So if the keyword argument is not used, then it will actually pick the algorithm that is specified here. You can also override if at all you wanted to override at cluster level or at session level. That being said, now if you don't want to compress, then you have to use none like this. It will make sure that the files are not compressed. Let's run this. This will take care of writing data from this data frame into Parquet files in this location. It is already done. Now we should be able to run this to see the file names. You can see the file name here. This time there is no snappy as part of the file name, which means the file is not compressed. Also, you can review the size of the file. It is 3758 bytes. Earlier it is around 3200. This time it is around 3800, which means the size of the file is a bit different when the file is not compressed. In this case, the size is not significantly different because we are actually dealing with very small dataset. Now let's use this piece of code. In this case, we are trying to use gzip compression instead of snappy compression. Let's run this. This will take care of writing the data in this data frame into Parquet files using gzip compression. We should be able to validate by running this. You can see the output here. It says .gz.parquet, which means the files are compressed using gzip compression algorithm. When it comes to size of the file, it is close to 3000 bytes. Now we can also do one more thing. We can also set the property to some other compression algorithm. Even in that case, we should be able to customize the compression behavior without passing compression keyword argument. Let me actually paste here. Now let me say set. As part of the set, let me specify none, which means I'm not going to compress the files. Now the property is set. Now let's copy this. Let's paste here. Let's remove the keyword argument compression equal to gzip. Now let's run this. You can see that the data frame is written into this location using Parquet file format. we should be able to validate by running this piece of code. You can review the output here. This time the file is not compressed, which means you can also customize the compression behavior using this approach. In this case, we have overwritten the property value from snappy to none. Once it is changed to none, whenever we try to use Parquet to write the data from data frame into files, instead of using snappy algorithm for compression, it will not compress the data at all. It will be applicable only for this session. Once the session is restarted, unless and until we set this property, it will not actually disable the compression. We can also set these properties at a cluster level. Whenever cluster comes up, it will take care of setting up this property. Based upon this property value, it will impact all your data pipelines wherever you are trying to use Parquet file formats. That being said, this is how you should be able to deal with compression while writing data from Spark data frames into Parquet files. As part of this lecture, let's go through the details related to different modes we can use while writing data from Spark data frame into files. First, let's create data frame by name Coalesce_df. When it comes to data frame, it actually have a attribute called as write. It is of type data frame writer. It exposes a function called as mode. We should be able to leverage mode to actually specify the mode while writing the data from data frames into the files. Let's review the help on mode. You can see the details here. Mode accepts one argument. It is nothing but save mode. As part of save mode, it can be append, overwrite, error, or error if exists, ignore. The default is nothing but error, which means if the target folder exists, it will just throw an error. That being said, you can also use mode as a keyword argument to any file format specific API, or even as part of save when we actually specify the file format using format. You can actually go through the details here. These are different ways where you can actually pass mode. So this is where we are actually passing mode using mode function on top of data frame writer. On top of it, we should be able to specify any file format based API depending upon the file format. You can replace this file format with a CSV or text or JSON or Parquet. Then you can actually specify the path. As part of the path, it will try to write the data from the data frame. Another approach is you should be able to use file format specific API such as CSV, JSON, Parquet on top of data frame writer like this. Once you specify API like this, as part of the API call, you should be able to specify the path to folder to which you want to write the data from the data frame. And then you should be able to use keyword argument called as mode, and you should be able to specify any of the modes we have seen earlier. Another approach is using format and save. Even with format and save, you should be able to use mode on top of data frame writer, and then you should be able to invoke format and save. It will exhibit the same behavior. Also, as part of save, we should be able to use mode equal to save mode in case if we would like to pass mode as keyword argument to save. So these are different approaches using which we should be able to specify the mode in which we wanted to deal with writing the data from a Spark data frame into files. Now let's perform few tasks to understand the behavior of error or error if exists, overwrite, append, etc. You can also try with ignore. When it comes to ignore, if the target folder exists, it will just ignore. It will not do anything with the data. Now let's run this. It will take care of creating an object by name username. When it comes to the default behavior, it is nothing but error, which means it will fail if the target folder exists. First, let's remove the folder courses. It is removed successfully. Now this will take care of writing the data from Coalesce_df in the form of Parquet files in this location. Let's validate the location. You can see that it contains one file. The name of the file is nothing but this one. Now if you try to run the same piece of code again, as the target folder already exists, this time it will fail. You can see here it is failing, saying the courses already exists. Even if you say mode equal to error or mode equal to error if exists, you will see the same behavior. Now if you want to overwrite the existing files in the target location, you should be able to specify mode as overwrite like this. It will take care of overwriting the existing files. Before running this, let's get the count on this location, then we'll actually take it further. I already have the piece of code to get the count. Let me copy that. Let me paste here. Now let's get the count. You can review the count here. The files contain 21 records. Whatever files we have as part of this location in the form of Parquet contain 21 records at this time. Now let's run this. In this case, we have specified mode as overwrite. We have invoked mode on top of data frame writer, and as part of Parquet, we have specified the target location. As we have specified overwrite with respect to mode, the existing files will be overwritten. Also, we can actually overwrite using this approach. Instead of using mode on top of data frame writer, we should be able to use keyword argument like this as part of API related to Parquet. Even this one will exhibit the same behavior. You should be able to run this. It will work in the same manner. Also, you should be able to use format and save combination. As part of save, you should be able to specify mode equal to overwrite like this. Even this one will work in the exact same manner. Also, we should be able to say dataframe.write.mode of overwrite, then format and save. Even that one will work in the same manner. Now, let's run this to review the details on this location. You can see that there is only one Parquet file. You can also run this. You can see that count is only 21, which means the existing files are overwritten with the new files. If you want to add the data in the target location without overwriting the existing files, then you should be able to use mode append like this. If you run this, it will actually add additional files into the target location. Now you should be able to run this. As part of the location, you should be able to see more than one files with Snappy and Parquet. Let me scroll down. You can see there are 2 files now. You can also run this to validate. This time we should be seeing 42 records. The reason why we are seeing 42 records is because we are actually using same data frame to actually write into the target location by using append. Already we have 21 records. Now again 21 records are added to the target location. That's why we are seeing 42. As we have seen earlier, when it comes to mode, we should be able to use as a keyword argument as part of Parquet, or we can also use a combination of format and save. As part of save also, we should be able to specify keyword argument, or we should be able to use mode of append like this, and then we should be able to use format and save to write the data in append mode into the target location. So these are the details with respect to different modes that are available to write data from Spark data frame into files. We have seen examples with respect to error or error if exists, which is default, and also we have gone to the details related to overwrite and also append. When it comes to ignore, if the target folder exists, it will neither throw error, it will not overwrite, it will not even append. The target location will actually have the same set of files. However, you will not be seeing any exception. Sometimes you might want to see if the target folder exists, then you don't want to do anything. If the target folder doesn't exist, then only you want to write the data to the target location. In those scenarios, ignore can be used. That being said, it is very, very important for you to understand the relevance of different modes while writing data from Spark data frame into files. Make sure you are really comfortable with it. Also, I have demonstrated using Parquet as a file format. However, modes is applicable for all other supported file formats. One of the important aspects with respect to writing data frames into files is to control number of files that are supposed to be created in the underlying file system. Typically, we use Coalesce. Sometimes we might have to use repartition as well. Let's go to the details about coalescing and repartitioning of Spark data frames. Coalesce and repartition are functions on top of the data frame, which means if you create data frame like this, you should be able to use coalesce or repartition on top of it by saying df dot, and we should be able to pass appropriate arguments. Do not get confused between coalesce on data frame and the coalesce function available to deal with null values in a given column. There is also a function by name coalesce under pyspark.sql.functions. I am referring to that here. It is for a different purpose. It is primarily to deal with nulls in a given column. The function which I am referring here, which is nothing but coalesce on data frame, is nothing but function that is available on data frame such as df. Coalesce is typically used to reduce number of partitions to deal with as part of downstream processing. Repartition is used to reshuffle the data to higher or lower number of partitions to deal with as part of downstream processing. Typically, Coalesce is used before writing data into the files from the data frame. Repartition is used somewhere in the middle. It might not be at the end. That being said, make sure to use a cluster with higher configuration if you would like to run this notebook and experience by yourself. The configuration which is recommended is 2 to 3 worker nodes using standard with 14 to 16 GB RAM and 4 cores each. However, I have actually provided the information that is required for you to understand all the nuances with respect to Coalesce and repartitioning. It should be most likely fine. If you are not comfortable, if you want to practice, make sure you spin up the cluster with this configuration and take it further. That being said, first I am actually creating data frame by name df. Then looking at the help related to df.coalesce, you can see that coalesce takes only one argument. It is nothing but num partitions. It is of type integer. You just have to pass the integer here. It will try to coalesce to that number. Keep in mind that there might be a different number of partitions in the upstream. Now, by actually passing a higher value than the number of partitions in the upstream, you will not be having any advantage of using Coalesce. It will be just be ignored. However, if the number of partitions that is passed as part of Coalesce is less than number of partitions from the upstream, then it will try to use those many partitions for downstream further processing. That being said, now let's look at the help related to repartition. When it comes to repartition, you can actually pass the number of partitions either greater than or less than the upstream number of partitions. You can also specify the columns based on which the data is supposed to be repartitioned. Based upon the characteristics of the columns that are passed here, it will actually decide the number of partitions. It might not be the same number which you have passed here. It also depends upon the characteristics of the data in the columns. Now let's perform few tasks to understand the difference between Coalesce and repartition. When it comes to repartition, it incurs shuffling and it takes time as data has to be shuffled to newer number of partitions. Also, we can repartition the data frame based on specified columns. Coalesce doesn't incur shuffling. We use Coalesce quite often before writing the data to fewer number of files. If you try to use repartition, it will take more time because it incurs shuffling. I have created a data frame by name df. If you look at the piece of code, I'm using spark.read.csv and passing this location. This location contains CSV files. Those files have header, and hence we are actually specifying header equal to true so that we can inherit the column names. And also to determine the data types, I'm actually specifying info schema as true. Now you can see that data frame is created without any issues. Now if you review the location here, there are quite a few files in this. There are close to 20 files. You can actually go to the files here. Now if you look at the number of partitions on this data frame, the number of partitions are nothing but 93. To get the number of partitions on data frame, we should be able to get the RDD from the data frame by saying df.rdd like this. RDD exposes get num partitions function. You should be able to leverage this and you should be able to get number of partitions that are involved with respect to the data frame. As of now, data frame df have 93 partitions. You should be able to use Coalesce like this to reduce the number of partitions. You just have to say dataframe.coalesce and you have to specify the number of partitions. You can see that the number of partitions are 16. I'm just using rdd.getNumPartitions so that we can review the number of partitions associated with this data frame, which is the result of df.coalesce with 16 as argument. When it comes to data frame df, the number of partitions is 93. If you try to pass the number greater than to that as part of Coalesce, it will not be effective. You can see here. I have set df.coalesce of 186. It will create a new data frame. When we try to get the number of partitions of this new data frame, you can see it is 93 only, which means it is not useful if you try to pass a number which is greater than the number of partitions of the original data frame to Coalesce. Now you can see the details with respect to repartition here. This will create a new data frame. You can see that it took 1.55 minutes when compared to Coalesce. Coalesce only took 0.04 seconds or 0.03 seconds, whereas repartition took 1.55 minutes. It also creates a new data frame. You can see the number of partitions here. The number of partitions is nothing but 16. The reason why it is taking time is because repartition incurs shuffling. Shuffling is a very expensive operation and hence it is taking time. However, sometimes we might want to repartition to higher number so that we get more compute to actually process the data. We should be able to specify the higher number with repartition. Also, we can pass arguments like this. These are nothing but column names. Using these two columns, the data will be repartitioned. As long as we have keys more than 186, it will work. If year and month combination doesn't have keys more than 186, then you might not get these many partitions. You can see that even this one took 1.22 minutes. It is because of the shuffling involved when it comes to repartition. With respect to repartition, you should be able to reduce the number of partitions and also you should be able to increase the number of partitions. Also, you can pass the column names as argument. As long as the unique values in these columns are greater than whatever number specified here, we'll be seeing those many partitions. However, if the unique values are less than whatever number specified here, then we might see different results. We might see the number of unique values in the number of partitions rather than the number of partitions specified here, or we might even see errors. I am not 100% sure at this time. You can experiment and you can figure out by yourself. That being said, one of the common uses with respect to Coalesce is to write to lesser number of files. Let's see how it is better compared to repartition. In this case, I have deleted the target folder into which I am going to write. It is deleted. First, I am actually writing to the target location without using Coalesce or repartition. If you look at the output, it took only 2.15 minutes to actually write the data into the target location. It is nothing but this one. it will contain several files. The files will have header because we have specified header equal to true. Also, the files will be compressed using gzip algorithm. Now this piece of code will give us the details about the files in this location. You can see the files here. There are 93 files. The reason why we are seeing 93 files here is because we have 93 partitions in the original data frame. We haven't used Coalesce or Repartition to write to fewer number of files, and hence we'll be seeing 93 files here. When it comes to the time, it took 2.15 minutes. Now let's see how long it took with Repartition. You can see that it took 3.19 minutes. So it took almost 1 minute more than writing directly. It is because repartition incurs shuffling. You can also review the files here. There are 16 of them. You can actually go through files. If you count them, there will be 16 of them. Now, as we have seen with respect to repartition, it took more time than writing directly. With respect to Coalesce, it took 2.67 minutes. It is greater than writing directly without Coalesce or Repartition, but it is less than Repartition. Also, you can review the files here. You can see there are 16 files. The reason why Coalesce is faster is because it doesn't incur shuffling. It is faster when compared to Repartition. However, it is slower when compared to writing directly. But we are able to achieve fewer number of files. Having fewer number of larger files is healthy with respect to data lakes or data warehouses or big data clusters. And hence, this is better compared to writing directly, where 93 files are written and most of the files are very small in size. For example, this file is only 33 MB. Almost all the files are close to 33-34 MB. Whereas the size of the files that are generated using Coalesce or Repartition are much greater than that. This file is 90 MB, this is 112 MB, this is 149 MB, so on and so forth. But Coalesce is faster than Repartition because Coalesce doesn't incur shuffling. This is how you should be able to write to fewer files using Coalesce, where Coalesce outperforms Repartition. However, if you want to write to large number of files than the original data frame number of partitions, then you have to use Repartition. Also, sometimes for the downstream processing, we might want to give a bit more compute power. One of the strategy is to use Repartition and increase the number of partitions. It will actually use a lot more capacity to actually process the data. In that scenario also, Repartition comes handy. But from the perspective of writing to files, we use Coalesce more often than Repartition, especially while writing to fewer number of files than the number of partitions in the original data frame.